So my voice is audible. Good morning. My voice is audible. Matmesh, my voice is audible.
Sir, your voice is audible.
Yes, sir, audible, sir.
Okay. You'll wait for one more minute because
Sure, sir.
then we start. Okay. We'll just recap what we seen last classes. Then we'll. So if we take unit 1, so yeah, only 2 questions, 11A and 11B. So 11A we have seen ellipse by eccentricity method, parabola by eccentricity method, hyperbola by eccentricity method, and after that we have seen cycloidal curves, and that is a cycloid. So when a circle moves in a straight line, if you just trace the path, that is a cycloid, and after that we have seen epicycloid. So a circle, it is moving outside a circle. So if you just trace the path, that is epicycloid. And similarly, in a circle, inside a circle, some circle is rotating. If you just trace the path, that is hypocycloid. So I already told you, if you take 11A, among the 6 questions, you'll have 1 question. So 11B, we have seen scales. I already told you when we have to go for scales. When the component size is big, okay, I want to draw in a drawing sheet, you have to go for reducing scale. But when the component size is very small, but I want to draw in a drawing sheet, we have to go for enlarging scale. So that time we have to apply scale. So there are nearly 6 scales are available, but in exam point of view, we have seen 3 scales. So plane scale, vernier scale, and diagonal scale. If we take plane scale, okay, only 1 decimal. So we can able to mark 2 units, okay, maybe centimeter, meter, something like that. We can able to mark centimeter and mm. We can able to mark 2 units, but only 1 single decimal. But if you take diagonal scale, so we can able to mark 3 units, but two decimal, maybe 19.28, 19.26, something like that. And similarly for vernier scale, so vernier scale we can able to mark 2 units, but 2 decimal. Okay, we have seen some problem based on that, and given some assignment also. Just go through that. So after that we have seen projection of a point. We'll just recap what are the things we have seen in the projection of point. So in the first quadrant, we are just keeping the point. In the first quadrant, we are just keeping the point. We are just projecting the front view and top view. We just projecting the front view and top view. We just keep a point in the first quadrant. So front view also will get a point. So top view also will get a you get a point. I already told you. So I give one small exercise. Make some paper or some waste note front sheet. So just make some that quadrant and just keep the point and try to visualize. Just keep the point and try to visualize. Even after this class, I'm going to start second unit, a line also. So just make some component like that. Just keep some line. Let's just imagine a pencil or something like that. Just keep and try to visualize. Okay, if you just do that, you can be expert in that. Okay, then later, if you keep some solids, very easy to visualize. Okay, and we have seen some cases of projection of point. A point is above HP, but in front of VP, that is first quadrant. So front T we have to take A dash. So top P we have to take A. I already told you above HP, behind above HP, and it may be above HP and that below HP will always comes in first quadrant. Above HP and below HP. So that height, above HP and below HP, that height will come always in the first quadrant. You'll get a dot. So front view means, okay, front view means, you have to remember this, front view means either above HP or below HP. So front view means, starting with a notation of dash. So front view means either above HP or below HP. So that will be projected on vertical plane. So either it may be, that is A dash. So it comes with dash. If it is the top view, so that will be projected only on the horizontal plane. If it is the top view, that will be projected only on the horizontal plane. That will be only projected on horizontal plane. So there is no notation of dash. If it is A, you have to use a notation of A itself, either in front of VP or behind VP, in front of VP or behind VP. Okay, so we have seen first case, the point is above HP but in front of VP, and we have seen second case, a point is behind VP but above HP. A point is behind VP but above HP, that we have seen. And third case, a point is below HP but behind VP. A point is below HP but behind VP, that is third quadrant. And we have seen fourth quadrant, point is below HP but in front of VP, in front of VP. So this we have seen, nearly we have seen 4 cases. And after that we have seen a point is on horizontal plane itself but in front of VP. A point is on HP, on exactly on the horizontal plane itself but in front of VP. So that we have seen. And sixth case, a point is on vertical plane itself but above HP. A point is on vertical plane itself. Okay, once again I think we'll just draw something and we'll see. We'll just remember and then we'll go for a second unit.
Sir, நீங்க வரையறதெல்லாம் தெரிய மாட்டேங்குது சார்.
One second, I'm just I'm starting. Okay. Can my screen is visible?
Yes, sir.
Okay, so we have seen first case, a point is here. So this is horizontal plane, this is horizontal plane, this is vertical plane, this is vertical plane. So this is horizontal plane, this is horizontal plane. So we have seen first case, a point is above HP but in front of VP. Okay, so front view always, okay, I already told you, front view means this height above HP or below HP will be projected on vertical plane. Okay, so the front view means either above HP or below HP, that will be projected on only on the vertical plane, only on the vertical plane. So this in front of VP or behind VP, so that distance will be projected only on the top view. So you have to keep this, okay, this distance that is in front of VP, either in front of VP or behind VP distance, always projected on top view, always projected on top view, always projected on top view. But always horizontal plane you have to rotate clockwise direction 90 degree. Always horizontal plane you have to rotate clockwise direction 90 degree. So that is a rule. Okay, we have seen first case, a point is above HP in front of VP, and we have seen second case, a point is above HP but behind VP, that is backside of vertical plane. And we have seen third case, a point is below HP, a point is below HP, a point is below HP but behind VP, a point is below HP but behind VP. We have seen third case, and we have seen fourth case, a point is below HP, a point is below HP but in front of VP, in front of VP. So we have to draw front view and top view. And after that we have seen a point is on horizontal plane itself, a point is on horizontal plane itself but in front of VP, a point is on horizontal plane itself but in front of VP. So front view will get here in the XY line itself, front view will get on the XY line itself. And next we have seen a point is on vertical plane itself but above HP. A point is on vertical plane itself but above HP. The point is on vertical plane itself but above HP, and that is already told you. If the point is here, you can consider either first quadrant or fourth quadrant. If the point is here, you can consider first quadrant or second quadrant. Okay, next case is a point is on horizontal plane itself but behind VP. A point is on horizontal plane itself but behind VP. So for this you can consider either second quadrant or third quadrant. And after that we have seen one more case, a point is on vertical plane itself but below HP. A point is on vertical plane itself but below HP. A point is on vertical plane itself but below HP. This we have seen. And there is one more case, a point is on HP and VP. That means it is exactly on XY line. A point is on HP and VP. There is only possibilities if the point is on XY line itself. So there is a possibility. We have seen 9 cases. So we have seen some problem. I already told you. So exam point of view, either they'll ask the word will be there. The word will be there. So you have to draw something like this. You have to draw something like this. You have to draw a tangent line like this. So you have to mention. So this is projection line. It should be very, very light. The point should be visible. The point should be visible. So something like this. Okay, the point should be visible. So you have to say some A dash. I'm just giving some example. You have to mention this is A dash. Okay, if it is the front view, if it is the first quadrant, so this is a dash, and you have to mention this line should be very, very light. So you have to mention the point. The point should be somewhat visible. You have to say A. So what is the distance? This is always, I already told you, this is always, okay, top E means always either in front of VP. Just keep this in your word. If you want to note on this, just note on this. Top E means either in front of VP or behind VP distance. Always this is common, even for projection of line also. So top E means either in front of VP or behind VP distance. So front view distance will be the front view distance from XY line. The front view distance from XY line is always above HP or below HP. The front view distance, the front view height will be either above HP or below HP. The top view height, so top view height will be either in front of VP or behind VP. In front of VP or behind VP. So this is the thing we have seen. So I already told you, for this topic alone, for projection of point alone, so there is a possibilities of any question, either it will be given in words. So your point is 20 mm above HP and 30 mm in front of VP. So that means 20 mm above HP means you will get 20 mm here. So 30 mm in front of VP means so top you will get 30 mm. Top you will get 30 mm. So you have to draw something. This line, this is called projection line. This is called projection line. It should be very light. It should be very, very light. So you have to use 2H pencil or H pencil or 3H pencil. Only this point, because we are just keeping the point. We're just projecting. So what is visible? Only point. Okay. We are just keeping the point and we are just drawing front view and top view. Only visible is the point. It's point alone. So this is A dash like this. So sometimes if 5 questions is asked, we are drawing a common reference line. That means everything in a common reference line. We have seen some problem based on that. I given one assignment also, and that is I'm not expecting you to submit in Google Classroom. So this topic I'm just leaving it to you. And sometimes the diagram will be given. So, okay, if you want to expert in that, I already told you. You just make a model like this. Just Just keep some small chalk piece, something like that. So just imagine you just imagine you're the observer. When you just see from here, what you get here. So what will be the height? Just try to visualize. And similarly, just keep a small object here and just try to see from here. So whatever your projection here, just try to rotate, something like that, try to visualize. So if you apply this, so then it will be very easy for you. Okay. So after this, we are going to see projection of line. So if it is if it is a projection line, just keep a pencil, something like that. Okay, just keep a pencil or small small stick. Just keep it something like this. So try to visualize. Okay. So if you do that, okay, it will be very easy. Otherwise, okay, if you go beyond that, okay, third unit and all projection of solid, then visualization become very, very difficult. Okay. And I already told you 11B, there is a possibilities of scale 10 marks. 10 marks, there is a possibility of projection of point. Okay. So we cannot be able to predict, but so 11B is among 4 questions, either plane scale, vernier scale, diagonal scale, or projection of point. Okay, among these 4 topics, you'll have 1 question, and possibilities of 10 marks also. Both you'll have 1 question from projection of point, 10 marks. So plane scale or vernier scale, diagonal scale, you'll have 1 question, 10 marks. There's the possibilities are there, right? Okay, so with this, I'm completing my first unit. That is conics, cycloidal curves, ellipse, parabola, hyperbola. Cycloidal curves are cycloid, epicycloid, hypocycloid, and scales. We have seen plane scale, so vernier scale, diagonal scale, projection of point and projection of point. Okay, so if you want, I already told you, just practice, make some models like this, keep some small chalk piece or some small tiny material and try to visualize. Okay, that is the best way of improving your skill. Okay, so with this I'm completing. So then we'll start now. One second. So one second, I'll take attendance. Once again, okay. So if you take unit 2, so only 2 topics. You'll have one question from projection of lines, one question from projection of planes or lamina. So what you're going to do in first unit, in projection of point, we just keep a point. We just keep a point in the first quadrant, second quadrant, third quadrant, and fourth quadrant. We are trying to visualize. But if you take unit 2, what we are going to do, we are going to keep the line in the first quadrant alone. Hereafter, we will not consider second, third, fourth. I already told you in first angle position we are following in India. So we are going to follow hereafter only first angle position, that is first quadrant. We're going to keep the component first quadrant. We are going to draw front view, top view. So top view we have to rotate clockwise direction 90 degrees. So there is a rule for second unit, third unit. We are going to apply that. Even fourth unit, fifth unit, some say same thing we are going to apply. So unit 2, we are going to keep the line in the first quadrant. We are going to keep the line. In the first quadrant. We are going to try to visualize. And one more topic is, so 12A is projection of line. So 12B is projection of planes or lamina. So I already told you what is lamina and solids. So lamina means 2-dimensional object. Okay, 2D. So solid means 3-dimensional object. So what is the difference? So lamina means circle, a rectangle, a square, hexagon, a pentagon, this and all. Lamina. Okay, this is 2-dimensional, negligible thickness, negligible weight. So just imagine there is a circle. So circle, there is no weight. Just imagine there is a pentagon, there is no weight. So just imagine there is a hexagon, there is no weight. Rectangle, there is no weight or negligible thickness. But if you take a solid, so that is 3-dimensional, and one more difference is it is considerable thickness and considerable weight. You have to remember this. Okay. And so what you're going to do now? So we're going to keep the line in the first quadrant. Hereafter, don't think of second, third, fourth. I already told you only for the projection of point alone. So we are applying first quadrant, second quadrant, third quadrant, fourth quadrant. So except that, we will not apply second, third, fourth. Hereafter only first quadrant alone. So what we are going to do in projection of line? So we are going to keep the line in the first quadrant. We are going to draw front view, top view. So 12A. So 12B is we are going to keep some lamina. We are going to keep the lamina. That is, it may be a hexagon, it may be a circle, it may be a pentagon, it may be a rectangle, something like that. So we are going to keep in the first quadrant. So don't think simply, but we are going to keep with somewhat inclination. We are going to keep with some inclination. Okay, there are some methodology to follow. So I already told you, if you want to expert, if you want to well versed, I already told you, you make some models like that. I already shown that. So make a model and try to make a model and try to keep the model and try to visualize. If you done that, you can be expert. You can get very good marks. Otherwise, it's somewhat difficult. Okay. So I'm going to start projection of lines. So before that, we'll see what is a line. It is a line. Straight line is defined as shortest distance between 2 points. Okay, a straight line is defined as the shortest distance between 2 points. A straight line is defined as shortest distance between 2 points. If you take a straight line, so this is the shortest distance between 2 points. Okay, so this is a straight line. Okay, straight line is defined as shortest distance between 2 points. Okay, you get a A, B, or P, Q, something like that. Straight line is defined as shortest distance between 2 points. If you take a line, you need length. If you want to solve the problem with respect to line, you need this length. Maybe 50 mm, or 60 mm, 70 mm, or 80 mm. So the length is required. So without that, we cannot even solve the problem. If you want to solve the problem, so we need this length. And not only that, Okay. So if you want to draw a line problems, we need length, maybe 50 mm, 60 mm, something. The distance is required. Then one more data is required. One more data is required. One more data is required. What does that means? Just imagine there is a line here. So from this point, if just take carry it only from hereafter only first quadrant. So you know this is vertical plane. So this is horizontal plane. Okay. So if you take this line is AB, the line is AB, the line is AB. We need the distance. The point A is what is the distance from HP as well as what is the distance from VP. We need this distance. Otherwise, we cannot able to solve the problem. We need this length. We need this length, maybe 60 mm or 70 mm. That is required. Otherwise, we cannot able to solve the problem. And similarly, the ends. So what is the distance from HP? What is the distance from VP? So without that, we cannot be able to solve the problem. There is one more thing. This what is this? This is above HP. This is in front of VP. This is above HP, and in front of VP, the distance is required. Otherwise, we cannot be able to solve the problem. Okay. So we need the length. The line length is required, and the ends. How much distance from HP and VP? So in front of VP, how much distance? Above HP, what is the distance? Okay, so like that, distance also required. And one more thing is, sometime it will be inclined. So now it is parallel. Okay, when you say parallel, you have to remember this. When you say parallel, the distance should be equal at any point. So here 20 mm means here 20 mm, here 20 mm. If you measure at any point, the distance should be equal, then it is called parallel. But here it is somewhat, so there is a possibility of line is like this. There is a possibility of line is like this with some inclination. There is a possibility of line is like this with some inclination. Okay. Now line is like this. Just imagine a line is like this. Okay. So it is somewhat inclined also. It is somewhat inclined with respect to horizontal plane. There is some inclination also. There are, if you want to draw problems based on line, you need length. What is the length of the line? 60 mm. And what is the distance from above HP in front of HP? The distance is required, as well as what is the inclination with respect to HP or VP. So without that, we cannot be able to solve the problem. Okay, a straight line means it is the shortest distance between 2 points AB. So if you want to solve the problem based on projection of line, you need the distance, you need length of the line, you need length of the line, maybe 60 mm, 70 mm. And similarly, the ends, okay, the point A or B, the end distance is required from above HP or in front of VP, the distance is required. Otherwise, we cannot be able to solve the problem. And what is the inclination with respect to HP or VP? Sometimes it will be inclined with HP, sometimes it will be inclined with VP. But exam point of view, they will ask inclined to both HP and VP. Just imagine. So there is a line here. So it is inclined to HP as well as inclined to VP. So the last problem based on this only. Don't think they'll ask very simple problems. In exam point of view, the last problem based on a line is inclined to HP and VP. A line is inclined to HP as well as VP. Like that only the last. Okay. So if you want to solve the problem based on line, you need length of the line. So what the end distance from above HP and VP distance is required. And how much inclination, either it may be with respect to HP or with respect to VP. So that data is required. Otherwise, you're not able to solve the problem. So types of lines. So there are 3 types. Okay, normal line. So when you say normal line, it is perpendicular to one reference plane. Okay, it is perpendicular to one reference plane. Okay, it is perpendicular to one reference plane. So now it is perpendicular to which plane? So this is, this is HP, this is VP. So it is perpendicular to, this line is perpendicular to HP, but parallel to, this line is perpendicular to HP, but parallel to vertical plane. This line is perpendicular to, when you just extend this, okay, with respect to this line. So this angle is 90 degree. With respect to this line, this angle is 90 degree. So then it is called perpendicular to one reference plane. So this is perpendicular to one reference plane and parallel to other plane. When you say parallel, you have to remember this. When you say parallel, the distance should be same at any point. When you say parallel, the distance should be same at any point. The distance should be same at any point. If you measure here 10 mm, if you measure 10 mm, if you measure 10 mm, if you measure 10 mm, then it is parallel. So here 9 mm, here 11 mm, here 13 mm, that is not parallel. Even 1 mm is not equal. So here 11 mm, here somewhere here 12 mm. So it is somewhat inclined only. So when you say parallel, the distance should be equal at any point. The distance should be equal at any point. So this case is a line is perpendicular to HP, but A line is perpendicular to HP but parallel to VP. So there is one more possibility is when you say normal line. So this is a normal line. When you say normal line, there is one more possibility is okay, a line is like this. A line is like this. A line is like this. Okay, line is perpendicular to VP but parallel to HP. A line is perpendicular to when you just extend this. When you just extend this. So with respect to VP, if you measure the angle here, if you measure the angle here, so here it should be 90 degree. Okay, so this is perpendicular to VP, parallel to HP. This is perpendicular to VP but parallel to HP. This line is perpendicular to VP but parallel to HP. So both are normal line. So what is normal line means? So perpendicular to one reference plane and parallel to another plane. A line is perpendicular to one reference plane, but when it is parallel to other plane, when a line is perpendicular to one reference plane but parallel to other plane, then it is called normal line. Okay, and second case, inclined line. Second case, inclined line. Okay, when you say inclined line, so it is inclined to only one reference plane. It is inclined to only one reference plane, but parallel to another reference plane. It is inclined to only one reference plane, okay, but parallel to another reference plane. It is inclined to only one reference plane, but parallel to other plane. Okay, I'm just doing one line here. Just see here. This is a line. Okay, this is a line with some inclination, with inclined to HP, with inclined to HP. For example, 30 degree. So 30 degree. So this line is inclined to HP, but parallel to VP. When you say parallel, the distance should be equal 30 mm, 30 mm, 30 mm, 30 mm. So when the distance is not equal, it is not parallel. Okay, when you say parallel, you have to keep this your word. Okay, you have to remember this. When you say parallel, the distance at any point, should be equal. When you say parallel, the distance should be equal at any point. Okay, so now the line is inclined to one reference plane, inclined to horizontal plane. So inclined at 30 degree to horizontal plane, but parallel to vertical plane. The line is inclined 30 degree to horizontal plane, but parallel to vertical plane, So that also inclined line. So that is one more possibility also is there. There's one more possibility. The line is like this. The line is like this. The line is like this. Okay, this is inclined to VP. This is inclined to maybe 30 degrees, something like this. Okay. So VP and HP. This is VP and HP. So now the line is inclined to VP and parallel to HP. When you say parallel, the distance should be equal. When you measure at any point, the line should be equal. The gap should be equal. Then it is called parallel. So if you measure from horizontal plane, it may be 30 mm means at any point it should be 30. So 1.30, one more at the end 32 mm means it is not parallel. So the case is a line is inclined, that is 30 degree to VP, but parallel to horizontal plane. A line is inclined at 30 degree to vertical plane, but parallel to horizontal plane. Okay, this is both are called inclined plane. So what is inclined line means? Both are called inclined line. So what is inclined means? So the line is inclined to one reference plane. The line is inclined to one reference plane, but parallel to other reference plane. So the case is the line is inclined 30 degree to HP or 40. So it may be any angle. Even 1 degree also it is inclined. Even 0.5 also it is inclined. Okay. So now it is inclined. This is inclined. So the line is inclined to HP, but parallel to VP. Line is inclined to HP, but parallel to VP. So that is one more possibility. The line is inclined to VP, but parallel to HP. Okay. So for this, what will get in the front view? For example, okay, here after only first quadrant. When you just see from here, what will get in the front view? So in the front view, that will be projected on vertical plane. You will get some inclined line like this, A dash, B dash. Front view means you have to mention A dash and B dash. So top view, what will you get? So top you will get reduced length of line. When you just see from the top, you will get a straight line, but reduced length of line. Okay, reduced length. That depends on inclination. The angle is 30 degree. So maybe when the length is 70 mm, you will get some 60, something like that. That depends on angle. Okay, for example, when the line length is 90 mm, but it is inclined at 89 degree. So maybe 9 mm, 10 mm like that, you'll get a length of the line. Okay. So in the front you will get original length. That is A dash, B dash with some inclination. What are the inclination? But top you what you'll get? You'll get reduced length of line. Similarly here. Okay. Top view. When you just see from the top view, you'll get AB with some inclination, AB with inclination, but original length. When you just see from the front, front, you will get reduced length of line. That is A dash B dash. That depends on inclination. Okay, so this is some logic you have to think. I already told you, if you want to familiar or if you want to expert in that, just make a model and just try to keep some pencil or small stick and try to visualize. We can able to understand. Okay. Anyway, after this, I'll show some animation also. Okay. So inclined line is, it is inclined to one reference plane, inclined to HP, but parallel to EP. So front you will get inclined line A dash B dash. Top you will get reduced length of line. That depends on angle. And similarly, inclined to HP. A line is inclined to HP, but parallel to inclined to VP, but parallel to HP. So top you will get original length of line. What are the inclination? But front you will get reduced length. Of line. So that depends on angle. So this is called inclined line. So normal line means perpendicular to one reference plane, but parallel to other plane. So inclined line means inclined to one reference plane, but parallel to other reference plane. So there is one more thing is that oblique line. That is oblique line. Exam point of view, this is most important. They'll ask only problem based on this only. So if they'll not ask problem, they'll not ask problem based on this. Then they'll not ask problem based on this, only oblique line. So what is oblique line means? It is inclined to both HP and VP. Inclined to both HP and VP. We'll just see this, and after that we'll see one animation. Then we'll come individual topics elaborately, one by one. So every cases we'll see elaborately. Okay, first we'll see last case, oblique line. So what is oblique line? So this is inclined to both HP and VP. Just imagine there is a line here. It is inclined to HP also, but inclined to VP also. So this is inclined. So this is a horizontal plane. So there's an inclination here also. Maybe 30 degree, 40 degree, something like that. Okay. But inclined to VP also. Maybe 40 degree, something like that. So front view what you get? You'll get reduced length of line. Okay. Observer has to be here. So front view what you get? Reduced length of line. So top view means you have to see from here. You have to visualize. So top view also will get reduced length of line. So front view also reduced length of line. So top view also reduced length of line. So we cannot apply standard simple method. We have to follow some methodology. For doing this. So I already told you this is most important. Okay, exam point of view, last only problem based on oblique line. Okay, so with this, okay, before there are some more everything we have to see elaborately. So before that, we'll just see some animation, then we'll come for continuing with this. You just see here, a line is perpendicular to HP. Okay, but a line is perpendicular to HP, but parallel to VP. A line is perpendicular to HP, but parallel to VP. Okay.
So line perpendicular to HP and parallel to VP. Line perpendicular to HP and parallel to VP.
So front view what will get? A line, but top view what will get? A point. So this horizontal plane, you have to rotate clockwise direction 90 degree. A line is
consider a straight line AB, line perpendicular to HP and parallel to VP.
Perpendicular to HP but parallel to VP. Just take A dash, AB means you will get A dash, B dash. So top view what will get? You'll get a point alone. Top view what will get? You will get a point alone. Top view what will get? You'll get a point alone.
Consider a straight line AB, Line
Okay.
perpendicular to HP and parallel to VP.
So if you take this is AB, so front view what will get? A dash, B dash. Top view what will get? Only B is visible. B is visible, but A is you have to mention in the bracket. A you have to mention in the bracket. A you have to mention in the bracket because so top view A is not visible. Top view A is not visible. Top view A is not visible.
Consider a straight line
Oh.
AB placed perpendicular to HP, line perpendicular to HP and parallel to VP.
Okay. So here what they're doing, just once again, I'll take okay, let's take here. Here the point they're taking, this is point number B, this is point number A. Okay, then now the line is, okay, just then now the line is, when you just extend this, when you say perpendicular, so with respect to here, this is 90 degree. Okay, this is 90 degree. When you say parallel to VP, the distance should be equal at any point. So they're taking the point is B and A. So front view what will get? So observer has to be here. So he has to see from here. So what will get in the front view? You'll get a B dash. You get B dash. So here what will get? You'll get A dash. So front view what will get? You'll get a straight line. So B dash and A dash. So top view what is visible? A is visible. So when you just see from the top, only A is visible. B is at the backside.
Line perpendicular to HP and parallel to VP.
Here, what is the height? This is above HP will comes here. This above HP will becomes here. In front of VP come below XY line. Okay. So the point, this is in front of VP, this is above HP. So this is always okay. Hereafter you have to,
Consider a straight line.
so hereafter you have to
line
consider one.
perpendicular to
Hereafter you have to
HP and parallel to VP.
So A dash, B dash. So top you will get a point. So this is first case number.
Consider a straight line AB placed perpendicular
So this is your
to
true line.
HP and parallel to VP. Its front view is projected onto VP, which is a line A dash, B dash, perpendicular to XY line having true length TL. The top view is
Next case is, so line is perpendicular to VP. When you say perpendicular to VP, so when you just extend this line and this, the angle should be 90 degree. When you say perpendicular, this is 90 degree. So when you say parallel, the gap between HP at any point, if you measure from here, 100 means, so if you measure from here 100, in one point, if the distance is not equal, then it is not parallel. So now the line is perpendicular to VP and parallel to HP. So the observer has to be here. So front view what will get? Whatever the point name, if it is AB, okay, if it is A is visible, B is at the, if the point is B here, B is at the back side. You have to mention A dash, B dash. Okay, front view means you have to mention, you have to remember this. Front view means A dash and B dash. So front view what will get? You'll get a point. So top view what will get? You'll get a straight line. That is AB. This horizontal plane you have to rotate clockwise direction 90. Just watch it.
line perpendicular to VP and parallel to HP. Consider a straight line.
Just watch it one more time.
Line perpendicular to VP and parallel to HP. Consider a straight.
Okay. So next we'll consider. I forgot to tell one case. Line parallel to both HP and VP. Line is parallel to both HP and VP. When you say parallel, both to HP VP means So from here distance is equal, 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 from here distance is equal. So line is parallel to both HP and VP. So front you also will get a line, top you also will get a line. Okay, so line parallel to both HP and VP. So front you and top will get a straight line.
Line parallel to both HP and VP. Consider a straight line AB placed parallel to both HP and VP.
Okay, so this is line parallel to both HP and VP.
Consider a straight line.
Okay, next thing is a line is inclined to VP. So when you say inclined to VP, so here inclined to VP, maybe some degree, maybe 30 or 40, something like that. And parallel to HP, when you say parallel, from here the distance is equal. At any point, the distance is equal. If you measure at any point with respect to horizontal plane, the distance is equal. So inclined to VP and parallel to HP. So front you what will get? So front you will get something here. Reduce length of line. Front you will get reduce length of line A dash and B dash. Reduce length of line A dash and B dash. So top you what will get? You will get incline line. Top you what will get? Incline line. So this is called some angle. This is called some angle pi. This is called some angle. Inclined to VP, that is some angle.
Line inclined to VP and parallel to HP.
Reduce length of line is original length.
Consider a straight line AB which is inclined at
Okay,
line inclined to VP and parallel to HP.
Reduce length of line. Original length.
Consider a straight line AB, line inclined to VP and parallel to HP.
Reduce length of line. Top will get original line. Whatever the theta, whatever the angle, you'll get same inclined line. So this is your rotate clockwise direction 90 degree. This is your rotate clockwise direction 90 degree.
Consider a straight line AB which
so this is one more case.
Line inclined to both HP and VP.
So reduce length of line. Reduce length of line. This is most important for exam point of view. Okay, what is the case is line inclined to both HP and VP. So this is a line. So this is inclined to VP also, maybe some angle. So inclined to HP also, inclined to HP also, inclined to HP also. So here maybe 30, 40, some angles will be given. So the line is inclined to HP as well as VP. So front you also reduce length of line, top you also reduce length of line, top you also reduce length of line.
Line inclined to both HP and VP.
Okay, a little this is most
line inclined to both HP and VP.
Reduce length of line. Reduce length of line.
The following shows the line AB
this
which
angle
is inclined to both HP and VP.
Okay, watch it. This was last time.
Line inclined to both HP and VP.
Reduce length of line. That depends on inclined to HP, inclined to VP. The reduced length is depends on inclined to HP, inclined to VP. Rotate clockwise direction 90, rotate clockwise direction 90 degree.
The following shows the line A.
Okay, we'll see cases one by one. We already seen this animation. We'll see one by one. So projection of straight line, a vertical line, or a line perpendicular to HP and parallel to VP. We're going to see the first case, a vertical line, a line perpendicular to. We already seen this, but anyway, we'll just okay, line, a vertical line, a line is perpendicular to HP. A line is perpendicular to HP. A line is perpendicular to HP. A line is perpendicular to HP, but parallel to VP. A line is perpendicular to HP, but parallel to VP. A line is perpendicular to HP, but parallel to VP. We take point A, B. So front you what will get? A dash, B dash, you'll get a straight line, A dash, B dash. So top you will get, when you just see from the top, only B is visible, only you'll get a point. So B is visible, but A is at the back side. There is a point A here. When you just see from the top, only B is visible, A is not visible. You have to mention the bracket. If some points are not visible, you have to mention the bracket A. First, we'll see this. The line is perpendicular to HP, but parallel to VP. The line is perpendicular to HP, but parallel to VP. XY line, a line is perpendicular to VP, but a line is perpendicular. Sorry, a line is perpendicular to HP. A line is perpendicular to HP, but parallel to VP. When you just extend, when you say parallel to VP, the distance should be equal. When you measure at any point, the distance should be equal. Okay. So when you say perpendicular to HP, mean the angle between here. So this line, when you extend this line, it will touch here. When this HP and angle, this angle should be 90 degree. When you say perpendicular, this is 90 degree. When you say parallel to VP, the distance should be equal. The distance should be equal. Okay, just watch it. So just take point AB, line AB. I'm just considering a line AB. I already told you here after no second quadrant, third quadrant, fourth quadrant. Just don't confuse with that. Only first quadrant. So whatever the top view, that you have to rotate clockwise direction 90. Whatever top you are getting, that you have to rotate clockwise direction 90 degree. Here after only first quadrants. Okay. Projection of line, projection of lamina, projection of solid, third unit. So everything we are going to apply only personal one, that is first quadrant. That's what we are following in India. Okay. So this is a line AB. So line is perpendicular to HP, but parallel to VP. Line is perpendicular to HP, but parallel to VP. So when the observer is see from here, when the observer see from here, when the observer is see from here, and the observer see from here. So you are just imagine you are the observer. So front you what you get? You'll get A dash and B dash. What are the length of the line? You'll get it here. So top you means you have to see from here. So top you what you'll get? Only you'll get this point. So you'll get A dash, B dash in the front view. So if the distance is okay, the distance is point number B is 20 mm above HP means the distance. What is the distance here? 20 mm above HP. If the distance is from here 30 mm means the point. So top you'll get a point A. B is at the back side. So what is the gap here? This is 30 mm. Okay. You have to remember this. Top view you have to consider only in front of VP or behind VP. So front view you have to consider above HP or below HP. Okay. The above HP distance will come on above HP distance will come on front view. Above HP distance will come on front view. In front of VP distance will come on top view. In front of VP will come on top view. In front of VP will come on top view. Okay, line AB. So here from your observer, so front view what will get? You'll get a you get A dash, B dash, A dash, and B dash. Front view is A dash and B dash. Front view is A dash, B dash. So top view means you have to see from here. Observer has to see from here. Okay, so you'll get a point. Okay, you'll get only one point. That is A is visible, but B is at the back side. There is a point at the bottom, but B is not visible. You have to mention the bracket. B is not visible. You have to mention the bracket. You have to mention the bracket. Okay, next we'll see second case. A line is parallel to both HP and VP. 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 That means the line is like this. The line is like this. So here also parallel. Here also parallel. Line is parallel to both HP and VP. That means from VP the distance is equal at any point. From HP the distance is equal. Say your distance is equal. Your distance is equal. So from here distance is equal. Distance is equal. So it is parallel to both HP and VP. So front you what you get? A line. So top you will what you will get? You will get a line. Case number 2. So case number 2 is line is parallel to both HP and VP. So line is parallel to both HP and VP. So just imagine a line AB. So front you what you get? You'll get a dash B dash. So top you will get from the top. When you see from the top you will get A and B. You'll get A and B. You get a line that is A and B. So this is a pictorial presentation. So how to draw it here? So front you what will get here? Front you will get something here. A dash B dash. You have to draw XY line, 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 a reference line. So top you will get, you have to draw a projection line, very light lines. So top you have to mention a point, top you have to mention a point, that is A and B bracket. So this is what final drawing. Okay, this side you'll get it. This is ortho pattern. So this is what you'll get it. So front view and top view, just watch it. So front view will get A dash, B dash, that is a vertical line. So top view will get a dot. So what you have to do? What is the rule? You have the first angle position. What is the rule you have to apply? So you have to rotate this horizontal plane clockwise direction 90. You have to rotate this horizontal plane clockwise direction 90 degree. Okay. And similarly, so here we'll get a straight line A dash, B dash above XY line. Below XY line we'll get AB. If this is the case, a line is parallel to both SP and VP. So front you will get A dash B dash, front you, top you will get AB. Okay. So for both the cases, okay, for the both. So this is your true length. What is true length means? So this is your true length. Whatever the original length, if it is 70 mm, here also you will get 70 mm. The length is 70 mm, here also 70 mm. Okay. So when you say true length, okay, when you say true length, original length. Okay, original length is 70 mm. Here also 70 mm, then it is true length. Okay. So here the line length is 40 mm. So here also same 40 mm. So then it is called true length. Here both the cases, here will get true length, here will get true length, here will get true length. We'll see third case. In the case number 3, a line is inclined to HP but parallel to VP. A line is inclined to HP and parallel to VP. A line is inclined to HP and parallel to VP. A line is inclined to HP and parallel to VP. A line is inclined to HP and parallel to VP. You see the third case. A line is inclined to HP and parallel to VP. So when you say inclined, so there are some angle here, maybe some angle 30 degree or 40 degree, something like this. The line is inclined. So inclined to HP and parallel to VP. When you say parallel, the distance is equal. The distance is equal. At any point, the distance is equal. So front you what will get? Front you will get an inclined line. Okay, inclined line. So whatever the length here, the length will be same. So whatever the theta here, theta is 30 degree. Here theta is 30 degree. So top you what will get? You'll get reduced length of line. You'll get reduced length of line. You'll get a reduced length of line, but straight line. So when you just see from here, top view, you get reduced length of line, but straight line. You get a reduced length of line, but straight line. Just watch it. So just take a line AB. Okay, so the angle is theta. So always we have to consider inclined to HP. We have to consider theta. Okay, inclined to HP, I'm going to use notation is theta. When the angle is inclined to HP, I'm going to use a notation of theta. So this is a front view. So you'll get inclined line A dash B dash. You'll get A dash B dash. Front view, you'll get A dash and B dash. So top view. So here also theta is same. So what are the theta here? Here also theta is same. So top view, you'll get A and B. Top you will get A and B. So top you will get a straight line, but reduced length of line. But if the length is 70 mm, maybe you will get 50 mm. That depends on theta. When incline more, when the angle is 85 degree, you will get more reduction in the length. Okay, just keep some pencil or some small stick and try to visualize. Okay, so what I'm saying is here, depends on this theta, this length will differ. So this is called top view length. This is called top view length. This is called front view length. This is called front view length. So front view length will be equal to this true length, but top view length will not be equal to this with respect to this true length. So true length means original length. If it is given 70 mm, the length of the line is 70 mm. But front view, the same length you'll get it. If it is 70 mm, you're also 70 mm. The theta is 30 degree, you're also 30 degree. But top view, the length is 70 mm, maybe you'll get 60 mm or 50 mm or 55 mm. That depends on this theta. That depends on this theta. You'll get reduced length of line, but straight line. Reduced length of line, but straight line. But top view length is not equal to true length. Top view length is not equal to true length. You just see the side. Okay. So this is a, so front you will get A dash B dash. This is front view. You'll get a theta. So top you will get a straight line AB. So whatever theta you'll get, theta will be same. And one more thing is, this gap is in front of VP. This gap is okay. Top view, always you have to consider top view means in front of VP. The distance is in front of VP distance, you'll get it. If the point A is 20 mm in front of VP means you have to consider from here 20 mm. The point A is 10 mm above HP means you have to consider here. Okay. Front view, you have to consider above HP distance. Front view means you have to consider this above HP distance, because when you just see from the front, only this above HP distance is visible. When you just see from the top view, only in front of VP distance is visible, but above HP distance will not be visible. The front view, only above HP is visible, so in front of VP is not visible. So you have to consider, okay, front view means you have to consider above HP, so top view means you have to consider in front of VP. If it is given problem, point number A is, so 20 mm above HP means, so from here A dash is 20 mm. So in front of VP is 30 mm means, so from here XY line we have to consider 30 mm. You have to consider 30 mm. Okay, this is case number 3. Inclined to HP, but parallel to VP. Parallel to VP. So front you will get an inclined line equal to true length. So whatever theta is same. So A dash B dash. So top you will get reduced length of line. Top view length is reduced length of line. So that depends on theta. You'll get but straight line, but reduced length of line. You will see the 4th case. The 4th case is a line is inclined to VP but parallel to HP. A line is inclined to VP but parallel to HP. A line is inclined to VP but parallel to HP. You'll see that case. The 4th case, a line is inclined to VP but parallel to HP. A line is inclined to HP but parallel to HP. Okay, when you say incline, so inclined to VP. So there are some degree here, 30 degrees, something like that. So inclined to VP and parallel to HP. When you say parallel, the distance is equal. At any point, the distance is equal. If you measure from at any point, the distance is equal. 30 mm means that always the gap should be 30 mm. So it is inclined to VP, but parallel to HP. Line is inclined to VP, but parallel to HP. So top you what you get? You'll get a inclined line. You'll get an incline. Whatever the theta here, you'll get same inclination. And if the true length is 70 mm, you'll get 70 mm. But front view, you'll get reduced length of line, but straight line. Front you'll get reduced length of line, but straight line. So this is, you have to consider pi. Okay. Inclined to HP, we have to consider theta. The problem also uses. So inclined to HP means we have to use theta. So inclined to VP, we have to use a notation of pi. If it is inclined to HP, we have to use a notation of theta used here. Inclined to HP, that is theta. Inclined to HP, that is theta. But inclined to VP, inclined to HP, we have to use theta. We have to use theta. But inclined to VP, we have to use notation of pi. Watch it.
Sir, 1 second. Second and third one mattu kaaminga sir.
No?
Second and third one mattu kaaminga sir.
Second and third one, you're asking what? I didn't get you. எதை கேக்குறீங்க எனக்கு புரியலப்பா. எதை கேக்குறீங்க எனக்கு? எதை கேக்குறீங்க எனக்கு புரியல. இது மட்டும் கேஸா? case கேக்குறீங்களா இல்ல?
Yes, sir.
Okay. Second one, no? Third one, no? Second one. So this is, okay, second one is line is parallel to HP and VP. Line is parallel to HP and VP. Okay. When the line is parallel to both HP and VP, so front view also you will get a straight line, top view also you will get a straight line. Okay. So when you say parallel, so here also distance is equal, 50 mm, 50 mm, 50 mm. It is parallel to VP. When you say parallel to HP, so 30 mm, 30 mm, 30 mm, 30 mm. So it is parallel to both HP and VP. So front view also you will get a straight line, top view also will get a straight line. So case number 3. Case number 3 is a line is inclined to HP. Inclined to HP with the angle of theta. When it is inclined to HP, we have to use a notation of theta. So, but parallel to VP. When you say inclined to HP, so with respect to horizontal plane, it is some angle. With respect to horizontal plane, maybe some angle 30 degree or 40 degree, something like that. But parallel to VP, when you say parallel, the distance should be equal from vertical plane. So parallel to vertical plane, that means, so from vertical plane, the distance is 30 mm from here, means at always the gap is 30 mm. So here 25 mm, here 28 mm, that is not parallel. When you say parallel, you have to follow this condition. At any point, the distance should be equal. Okay, so now it is inclined to HP, but parallel to VP. So front view, what will get? You get an inclined line. So whatever the theta, that will be equal. But top view, what will get? When you just see from the top. Top view means you have to see from the top. What will get? You will get a reduced length of line. 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 A straight line. You will get a reduced length of line. Straight line. So this is third case. So fourth case we have seen. So fourth case just now we started. A line is inclined to VP, but parallel to HP. A line is inclined to VP. So when you say inclined to VP, this is some angle. With respect to a vertical plane, there is some inclination, maybe 30 degrees, something like that. So inclined to vertical plane and parallel to horizontal plane. When you say parallel to horizontal plane, the distance should be equal at any point. 30 means always the gap should be 30. The gap is 20 mm, means always the gap should be 20 mm. Then it is parallel. The line is inclined to vertical plane, some angle, but parallel to horizontal plane. Okay, when you just see from the top, so what you get? You'll get a straight line. You'll get a straight line. Sorry, you'll get an inclined line equal to this angle. This you have to use only. You have to use a notation of pi. So when it is inclined to HP, we have to use a notation of theta. So when it is inclined to VP, you have to use a notation of pi. We have to use a notation of pi. This we have to use notation of pi. You have to use notation of pi. So top view will get inclined line AB. It is equal to true length. Whatever the true length, what is true length? So if it is 70 mm, here also 70 mm. So this is called true length. So true length and top view length will be equal. If it is 70, this also 70. But in front view, okay, you have to see from the front. When you just see the front view, so what happened here? The length will be reduced. Okay, so that depends on pi. Maybe you'll get A dash, B dash. Maybe if the length is 70 mm, the only length is true length is 70 mm. Maybe 65 or 60, 50. That depends on pi. So you have to remember one more thing. So inclined to HP, you have to use a notation of theta. So inclined to VP, you have to use a notation of pi. So front you will get A dash, B dash. So top you will get inclined line with the angle of pi. What is the rule you have to follow? Horizontal plane you have to rotate, clockwise direction 90. Horizontal plane you have to rotate, clockwise direction 90 degree. Okay. So front you will get a straight line, but reduced length of line. Okay, so this is your true length. This is top view length is true length. So equal to whatever the original length. But front view length will be reduced length of line. That depends on pi. So front you will get straight line, but reduced length of line. So compared to this length, maybe if the length is 70, maybe 65 or 60 or 70, maybe 58. So that depends on this length and pi. So you'll have a reduced length of line. Okay, I mean the angle is more. Okay, what happened? Maybe the reduced length will be more. Okay, reduced length will be less. Okay, that depends on this pi. Here 70 அப்படினா maybe here 70 and 10. Okay, here you'll get 68. Here 70 and 50 degree. Maybe you'll get 50 mm. So that depends on pi and true length. You'll get reduced length of line. So when it is inclined to VP and parallel to HP, in the front view you will get a straight line. So top you will get an inclined line. So you have to remember this is most important for basics. Okay. So next after that we are going to see most important case, inclined to both HP and VP. Okay. So inclined to HP we have to use notation of theta. So inclined to VP we have to use notation of pi. We have to use notation of pi. We'll see the last case. We'll see one more case also, but that is not important for exam point of view, but we'll see this case. A line is perpendicular to both HP and VP. So this is most important for exam point of view. So based on this only you have a problem. This is XY line, horizontal plane, vertical plane. So this is a line AB. It is inclined to HP as well as VP. So here there is an inclination with respect to horizontal plane. Inclination with respect to horizontal plane. So if it is inclined to HP, we have to use rotation of theta. This is inclined to VP. Inclined to VP. We have to use notation of pi. So when it is inclined to HP, we have to use notation of theta. When it is inclined to VP, we have to use notation of pi. So this is a front view. This is a top view. So front view also you will get a reduced length of line, but is somewhat inclined. So top view also you will get a reduced length of line. So that is we have to use another two notation, alpha and beta. So alpha and beta. So front view length, okay. So this is inclined to HP and VP, inclined to HP and VP, inclined to HP and VP. So this is theta and pi. So whatever this inclination, you will not have it because here also inclined, here also inclined. You'll have some different inclination here. So front view and top view, you'll have a different inclination because both it is inclined. So inclined to HP as well as inclined to VP. So because of that, you'll have some different inclination, that is alpha. We have to consider. So front view length means you have to consider alpha. So top view length we have to consider beta. This angle we have to consider beta. This angle you have to consider beta. Okay, we'll just see one more time. This is most important. A line is inclined to HP and VP. A line is inclined to both HP and VP. So inclined to HP, we have to use a notation of theta. So maybe 30 degree. So inclined to VP, maybe 40 degree. Inclined to VP, maybe some 40 degree. Sometimes will be given inclined to HP, inclined to VP distance will be given. Okay, inclined to HP 30 degree. So inclined to VP 40 degree. So front view what you'll get reduced length line. So top view also you'll get a reduced length of line, inclined reduced length line, but inclined. Both side reduced length line, inclined.
Sir, உங்க voice
This
break
angle
ஆகுது
we
sir.
have to.
sir.
Yeah. Okay, once again. Oh, my voice is audible. Oh, my voice is audible. Oh, my voice is audible.
இல்ல சார் இன்னும் break
My
ஆகுது.
voice is audible. Nava?
No sir, still is like that.
Echo mic.
இப்ப கரெக்டா இருக்கா?
இப்போ okay sir.
Okay. So line is inclined to both HP and VP. Line is inclined to both HP and VP. So it is inclined to both HP and VP. So this is a front view and top view. So front view what will get? Inclined line and reduced length of line. Inclined line and reduced length of line. So this angle we have to consider alpha. So front view inclination we have to consider alpha. Front view inclination we have to consider alpha. So top view also will get a inclined line but reduced length of line. You have to consider beta. So what are the things you have to remember? So inclined to HP. So inclined to HP. So that is theta. Inclined to HP is theta. Inclined to VP, that is pi. Inclined to VP is pi. Inclined to VP is pi. So front view also will get a reduced length of line, that is A dash B dash. Front view means you have to mention A dash B dash, and also inclined line. Whatever the line, this line will be reduced length, and you'll get somewhat angle also. You'll get some different angle. So this is alpha. So front view length inclination is called alpha. So top view length inclination is called beta. Okay, I'll repeat one more time. So theta is inclined to HP. 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 Pi is inclined to VP. Pi is inclined to VP. And alpha is, see, because when you just see from the front, you'll get inclined line, but reduced length of line. So alpha is front view length. Alpha is front view length angle. Front view length angle. Alpha is front view length angle. And when you just see from the top, you'll get inclined line, but reduced length of line, but different angle. That is beta. So top view length angle, top view length angle. So in exam, sometimes they'll ask to find out theta, pi, alpha, beta. Sometimes they'll ask to find out front view length. So what is front view length? Means you have to measure this distance. This is front view length. Okay. This is line length. This is what? True length. This is called true length. So what are the possibilities of question is asked? So sometimes some other data will be given, we have to calculate true length. So that is the possibilities of question. Sometimes, so theta pi will be, we have to calculate. Sometimes you have to calculate theta pi. Sometimes you have to calculate alpha beta. Sometimes you have to calculate alpha beta. Okay. So sometimes you have to calculate front view length. This length is called front view length. This length is called front view length. So front view length we have to calculate. Sometimes we have to calculate this top view length. Sometimes you have to calculate top view length. Some data will be given, something we have to calculate. So what are the possibilities, sir? So either true length will be given, we have to calculate some other data. Sometimes you have to calculate this original length of the line. We have to calculate. Sometimes you have to calculate this theta. That is inclined to HP. Sometimes you have to calculate this pi. So pi is inclined to VP. So what is alpha? Front view length inclination. Is called alpha. So beta is, so top view length inclination. That we have to calculate. Sometimes you have to calculate front view length. This is called front view length. Sometimes you have to calculate front view length. Sometimes you have to calculate top view length. So among this, any questions will be there. Okay. So we'll see one more case. Okay. So when you just rotate, you'll get something like this. When you just rotate, you get something like this. This is what you'll get. Front you'll get alpha, beta. So when you rotate clockwise direction 90 degree, when you just rotate clockwise direction, rotate 90 degree. This horizontal plane, you have to rotate clockwise direction 90 degree. So what you'll get here? You get something like this. So front view length, A dash, B dash with some inclination, that is alpha. So top view length with some inclination beta, that is AB. Top view length with inclination beta, AB. This sometimes you have to calculate true length, sometimes you have to calculate theta, sometimes you have to calculate pi. Some data will be given, sometimes you have to calculate alpha, beta, front view length, or top view length. Among this, 1, 2, 3, 4, 5, 6, 7. Some data will be given, something you have to calculate. Something you have to calculate. If you want to expert, if you want to familiar, you have to keep, just make some something like this, some board, something like this. But keep some pen or some small sticks and try to visualize. Then you can be well versed in this. You will see one more case. Okay, so the case is a horizontal line. So for this, there is no animation. So 6 case, a horizontal line. A line is perpendicular to VP, but parallel to HP. A line is perpendicular to VP, but parallel to HP. A line is perpendicular to VP, but parallel to HP. A line is perpendicular to VP. So a line is like this. So this is called a horizontal line. A line is perpendicular to VP. When you say perpendicular, so the angle should be this line, and this line should be 90 degree. And parallel to horizontal plane, when you say parallel, the distance should be equal. So this is A and B. You just see in the front view what you get. When you just see in the front view, so you have to see from here what you get here. So point B is visible. You get a point here. B dash is visible, but A dash is at the back side. You have to mention the bracket. You get a point alone. So you have to mention a point. You have to mention a point alone. So B dash is visible. A dash is at the back side. You have to mention the bracket. You have to say like this: a point, B dash, and A dash is at the back side. Okay. And top view, what is visible? When you just see from the top view, you'll get a straight line like this. You get a straight line like this. You get a straight line like this. AB. You'll get a straight line like this, AB. So you'll get a straight line like this, AB. When you rotate clockwise direction 90 degree, when you rotate clockwise direction 90 degree, you'll get something like this. Okay? So until you get a point B dash alone. So A dash is at the back side. A dash is not visible. And just see from the front here, A is not visible. You have to mention A dash at the bracket. So top you will get AB. Top you will get AB. Okay, top you will get AB. So if you want to draw its projection, if you want to draw a projection of a straight line, that means you have to draw front view and top view. You will not consider side view and all. Okay, when you say we have to draw a projection of a line, means that is front view and top view alone. Front view and top view alone. Front view and top view alone. You will see one simple case. See one simple case, and we'll close. The next class we'll see some more simple cases. Later we'll go for complicated problems. Okay, note on this problem. Simple problem. A line AB, line AB, a line AB, 60 mm long. Okay, note on this simple problem. A line AB, 60 mm long. A line AB, 60 mm long. A line AB, 60 mm long. A line AB is 60 mm long. A line AB is 60 mm long. A line AB is 60 mm long. Line AB is 60 mm long. Has its N capital A. As 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 its N capital A. 20 mm above HP. As its N capital A. 20 mm above HP. As its N capital A. 20 mm above HP. As it in capital A. 20 mm above HP. And the same point A is 30 mm in front of VP. 30 mm in front of VP. I'll repeat one more time. Line AB is 60 mm long. As it in a line AB is 60 mm long. As its in capital A 20 mm above HP. Capital A 20 mm above HP. Capital A 20 mm above HP. And 30 mm in front of VP. 30 mm in front of VP. 30 mm in front of VP. Full stop. The line is kept parallel. The line is kept parallel to both HP and VP. 30 mm in front of 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 VP. Line is parallel to both HP and 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 VP. Draw its projection. Line is parallel to both HP and VP. Draw a projection. Line is parallel to both HP and VP. It is parallel to both HP and VP. Parallel to both HP and VP. Parallel to both HP and VP. Horizontal plane as well as vertical plane. Just try to visualize. We can start the problem. So it is given like this. A line AB. A line AB is 60 mm. Line AB is 60 mm long. A line AB is 60 mm long. The point A. Okay. A is 20 mm above HP. Okay. The point A is 20 mm above HP and 30 mm in front of VP. And one more condition is given. The line is parallel to both HP and VP. Line is parallel to both HP and line is parallel to both HP and VP. Line is parallel to both HP and VP. Okay, just we'll try to visualize, then we can start with the problem. Hereafter only first quadrant, so there is no second, third, fourth. Okay, so line is like this. The line is like this. A line is like this. Okay, so what are the conditions given? Line AB. Line AB, it is given like this. Line AB. Okay, line AB, it is given like this. Okay, line is given AB. Line is given AB. So it is given like this. 60 mm long. Line AB 60 mm long. And this point number A. This point number A is so 20 mm above HP. 20 mm above HP. So from here, from horizontal plane, 20 mm above HP. 20 mm. The point A is 20 mm above HP. 20 mm above HP. The same point A is 30 mm. Same point A is 30 mm in front of VP. 30 mm in front of VP. 30 mm in front of VP. And one more condition is given. More condition is given. The line AB is parallel to both HP and VP. When you say parallel, from your distance is equal, from your distance is equal, from your distance is equal. This is parallel to HP. Parallel to HP. When you say parallel to VP, so from your distance is equal, from your distance is equal, from your distance is equal. So fronty what will get? Fronty will get a fronty what will get? Fronty what will get? Will get a straight line. What is the distance? Will get a straight line. What is the distance? Will get a straight line. It is fronty always it should be above HP. So top you always it be in front of VP. So okay. So fronty also will get a straight line. A dash B dash. Top you also will get a straight line. So fronty means you have to see from here. Okay, when you just see from front, you'll get a straight line of 60 mm. That is front means you have to mention A dash B dash. So what is the height of this line? 20 mm. So top you have to see from here. Top means you have to see from here. Top means you have to see from here. When you just see from here, you'll get a line like this. You'll get a straight line like this. You'll get a straight line like this. That is 60 mm straight line like this. AB. So what is the gap of this line? That is in front of VP, 30 mm. In front of VP, that is 30 mm. Okay, I'll just do it. I'll just do this problem. Okay. Okay. So what you have to do? So what you have to do? Just the scale. So 20. Okay, you have to draw a XY line. So you have to draw a XY line. You have to draw a XY line like this. Just draw a XY line like this. Then what you have to do? Then what you have to do? So above HP distance is 20 mm. So from here 20 mm when you scale, from here 20 mm, from here 20 mm. So from here 20 mm. So draw a line like this. Draw a line like this. Okay. Draw a line like this. Okay. Draw a line like this. Then draw a line like this. Then what you have to do? Then what you have to do? So locate a point here. Locate a point here. A dash. Locate a point here. A dash. The length of the line is 60 mm. The length of the line is 60 mm. So from here with the value of 60 mm, from here with the value of 60 mm using scale, locate the point here. So this gap is 60 mm. The 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 gap is 60 mm because the length of the line is 60 mm. So locate something like this. So top view, what you have to do? So top view is you'll get a line only, but gap is 30 mm. Gap is 30 mm. So from here with a gap of 30 mm. From here with a gap of 30 mm. So from this, draw a vertical projection line. It should be very, very light. You can use 2H pencil or 3H pencil or H pencil. So draw a projection line. In front you will get a line, top you will get a line that should be visible. That should be darkened. You can use HB pencil or 2B pencil. So front you will get a line, top you will get a line. This is another projection line, which should be very, very light. So from this, with the gap of 30 mm, okay, a point here. This is A. So from here, draw a horizontal line. This is B. In exam, so this is your top view. So this is your front view. This is your front view. Okay, in exam, only this A dash B dash the line should be visible. This A B line should be visible. You have to mention top view, front view. So you have to say that this is 60 mm. So this is a dimension 20. This is a dimension 30. So that's all. Okay, this is a solution for this very simple problem. I already told you in exam point of view. So inclined to both HP VP, they lost. Inclined to both HP VP, they lost. Okay, once again I'll take attendance. If you have doubt, we can. Okay, if you have any